Okay, so this video is about factoring and solving perfect square trinomials. So I wanted to start us off on this video by looking at the different special factoring shortcuts. It all is based on you knowing this for your different shortcuts, all right? So I'm going to do the first three problems by using shortcuts. Keep this in mind though. I can always do these by goal number factoring. Goal number factoring will work 100% of the time. So in the first problem here, I recognize that this is a perfect square. I know this is a perfect square, and I notice they're subtracting it. So then I can factor this to 2x plus 5 and 2x minus 5. I notice that this first term is a perfect square. I notice that this last term is a perfect square, and I notice that this term is 2 times x times 3, which tells me this can factor to x plus 3 times x plus 3, which could be written as x plus 3 quantity squared. Similarly with number 3 here, I know that this is a perfect square. I know that this is a perfect square. I notice that the middle term can be found by taking negative 2 times 3x times 1. That would give me negative 6x. So that tells me this will factor to 3x minus 1 and 3x minus 1, or 3x minus 1 squared. Now again, I did these all by using these algorithms. You can always do goal number factoring and you'll arrive at the exact same answers. The second thing that I wanted to focus on with you guys was, what if they ask us to solve a problem? Okay, so instead of it just being a factoring, what if the problem says this: 25x squared minus 10x minus 1 equals 0. Now, not only can I factor it, but now I can also solve it because it equals 0. Now, I'm going to continue to use the shortcuts. Remember, you can always do this by goal number factoring. All right, I notice this is a perfect square. I notice that this is a perfect square. But you know what? It's not a perfect square for negative 1. So let's try goal number factoring here. Let's try goal number factoring and make sure that this works. So let's see. I have a goal number of negative 25. I have a middle term of negative 10. That means my factors have to be negative 5 and negative 5. But that doesn't multiply to give me negative 25, so that won't work. This is actually prime. It won't work. All right? So let's look at another one. Let's say that I have x squared plus x plus 1/4 equals 0. All right, I threw a fraction at us here. So I recognize that this is actually x being squared, that's a perfect square. 1/2 being squared, that's a perfect square. And I know if I take 2 times x times 1/2, I get 1x. So I know that this can factor to x plus 1/2 times x plus 1/2 equal to 0. Now, because I have the exact same factor, I know that all I have to do to apply the zero product property is set one of them equal to 0 and solve, giving me x is equal to negative 1/2. This actually is telling me what this means is the vertex of this parabola is at x is equal to negative 1/2. It's also telling me it doesn't really go through the x-axis, it goes to it and kind of bounces off of it. All right? So let's try one last one here. Let's say that we have x squared plus 4x plus 4 equals 64. All right. So let's see for this. How would I do this? Well, there's a couple of different ways to do this. This is not going to make a whole lot of sense at first because we have kind of been of the note that we have to have it equal to 0 in order to be able to solve a quadratic. But one thing that I recognize right away is that this trinomial right here is perfect. All right? It's a perfect square. So I know that this can factor to x plus 2 times x plus 2. And I'm going to leave it equal to 64. This is really x plus 2 squared is equal to 64. Now, this is what we're going to be focusing on more down the road for us. All right, so for this current test, we're not going to worry about these. But how I would do this now is use another technique called square roots. All right, now I know that the square root of a square, they are inverse operations. So the square root of x plus 2 squared is just x plus 2. But here's where it gets a little crazy. I know that this square root of 64 is 8, but because it was a quadratic I was solving, I need to use what is called positive and negative representation, or plus or minus 8. This now creates for me two equations to solve, and it's similar to the zero product property, but a little bit different. One is x plus 2 is equal to 8. The other equation is x plus 2 is equal to negative 8. I solve the first one, I get x is equal to 6. I solve the second one by subtracting 2, I get x is equal to negative 10. This process is going to be something that we study a lot of when we do this thing called completing the square. All right? Hope this helps. Good luck to you, and let me know if you have any questions.